Go to TAPgiles.com to learn dreams, engage my services, and support the channel. From time to time, people ask how to make a scaling ball like this. So, like, I can scale it up by using R2. Now it's a bigger ball, but have it like be physical and moving around and collidable and all that. I can shrink it as well. You can see it getting smaller. So you'd obviously start with making a ball like that. And so you want it movable, rolling around, so make it movable. And I'll just lower the physics cost, because then it just has one physics sphere to simulate, and then it's closer to the shape of the ball. And then you might say, oh, I want to keyframe it so that it's bigger. There we go. Let's make it smaller to start off with, and then keyframe it bigger. There we go. And then we play time, and then when we turn on a keyframe, even though we just kind of change the scale of it effectively, the keyframe can only record an actual transform of a object. A transform is the position and the scale and the rotation of the object. So that's the only way it can record that. So when you activate this keyframe, it's setting the position as well as the scale, which isn't what we want. So what we need to do is like put this into a group. So if we have just a chip, group it up with the chip. Now that keyframe is setting the position and stuff within that group. And we can make this non-movable so that it moves with the group, and then make the group movable. And then play time and it falls as normal, and then you turn on make it big and it makes it big, yay! But within the group and wherever that group is. So you can even do stuff like, let's add a mover to it, and we'll have it affect the group. So now when we turn the keyframe off and on, it's being pushed to the right, and then when we turn it on, it's still being pushed to the right, but now the ball is bigger. But it's kind of freaking out and doing weird stuff because we're actually setting the size of the ball constantly every frame with this keyframe. Which means that we're, because this is a different size, we're changing the mass, because the density is like, the size times the density is the mass, how much it weighs. So when we turn this off, it's smaller and it weighs less. And then when we turn it on, it's bigger and weighs more. And that messes with the physics simulation. And that will tend to do weird things to physics engines. If we turn on keep changes, then we can turn it on and then turn it off, and it will stay that bigger size. And then the physics can do whatever it likes because we're not setting the mass every frame. So we can even do stuff like use a signal manipulator to make a pulse. Every time we turn this on, it will send a brief signal to power this for a brief time. So then we can go boop, and it turned big and carried on simulating as normal. So what we want to do is make it so that this doesn't affect the mass of the object too much. So now it's really tiny. If we leave keep changes off for now, so it's kind of still messing with the physics in weird ways, because the group is movable, so it looks for a sculpt inside it, or many sculpts inside it, to figure out what mass it has and what collision and all that. So because this is the only thing, then it's all of the density of this group is in this object. So turning this on and off still affects the mass of the object a lot. But if we do something like copy this over here and then make that normal density, so this is the one on the left with no density, and we'll make that green, and I'll make this one red, and that has normal density, then it will be mainly using the one on the right as the density, and then we just make sure it's not. And the one on the right won't scale, So when we change the mass of the one on the left, the way the overall group moves isn't affected very much. But we still want the collision and stuff of the one on the left, and we want this to be kind of in the same position as well. So what I'm going to do is put that on a grid point, make the grid really big, and then put it on a grid point. And then we can easily just grab this object from the center instead of the surface. So then if I record into the keyframe and just forget what that keyframe was, and then I grab it from the center, I can make it big from the center like that. And then we can move this just over to the same spot. Press triangle to snap it to the same spot. We don't need that anymore. Okay, so the whole thing is still moving fine, but we can make the green one big, but that like red one doesn't need to do anything really. It just needs to exist so that it can be used for the mass. So if you compare the mass of these two objects, the weight, this is 26 kilograms and this is 0.001 kilograms. So this has a lot more effect on the way the object moves than this. Even when this scales up, it's still very tiny compared to it, and that's why this works. So this doesn't need to be visible or collidable, and then we want to move it back in, and this one is visible and collidable because that's the actual ball that we see growing and shrinking. And now we can just make it big at any point in time, and we can like wait until it settles, and it suddenly collides a lot with the object, so it kind of bounces out. But the physics works properly for it, just fine. So then, if we go and make another keyframe for when it's small, we'll just set the position there. Let's go this out, and now we have like a small one and a big one. So we can put that into a timeline and just scale between them. Just make sure they're both on keep changes. Yeah, so it's getting bigger over time, but it kind of disappeared. And it popped out the bottom of the thing, and all sorts of weird stuff can happen because, again, we're changing this all the time, and we just want to like flash it on for a moment. So if we use that pulse trick again on the actual timeline, so this can be at any point during this, and then only when the timeline turns on, it'll like set it to that point, or set it to that point, or set it to that point when we turn on the switch. But yeah, at the minute it won't really do much because it'll just stay at the start. So if we have a value slider wired into the playhead, that means we can like tell it what part and what size we want this ball to be, and then we could turn this on to make it that size. So if we play time, I want it to be 0.7 of this scale, so now it's 0.7, and now I want it to be 0.3, and now it's 0.3. But the problem with just leaving it on is because we're constantly setting that size, so it's it freaks out the physics, as we said. So if you wanted this to constantly keep updating this, you could do something like use a timer and have it trigger every like 0.1 seconds or something. So every 0.2 seconds, I'll just make it bigger so it's really obvious. Every 1 second, it will rescale this to whatever this is. Okay, and at the minute it's not doing anything because it's not changed, and then I'll just change it. I'll change it again. That's all working fine. And if this was pretty fast, then it gets more seamless depending on like the difference in scales. So that's kind of how you can scale it over time, sort of thing. And that's basically how I did that little demo scene. So I'm controlling that the size that I want with L1, L2 and R2, and that's about it, and it just kind of keeps on setting it. it actually checks to see if it's changed from the last time it set it, and if it hasn't, then it won't flash on the timeline. But that's just like a nuance. So now we can like actually have growing snowballs as you move them around and stuff. Cool. Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.